hope this is not recording. I'm waiting for our assignment to load. So hopefully you're not sitting here watching this like I am. Hey, there we go. Alright. Now, I did those solutions, posted them online. Alright, we do have a day 3. Okay. What I want is day 2, I believe. These guys, this was here. Alright. Okay, I hope this is recording. I'm still, even though I made some videos last year, I still have difficulty making these videos, and sometimes they just don't record. Sometimes they record the video without audio or vice versa. So hopefully this will help. Alright, so these rational equations. I had posted solutions to our previous one, so this time I thought I'd make a video. We have two terms on the left-hand side. We have a single term on the right-hand side. Our technique for these rational equations is to get a common denominator. So I want to look at this number 1 and write its denominator of 1. So I need denominator of x plus 2 times the quantity x minus 2 for every term. This first term, it's missing this factor of x minus 2. So I can't just come in and put it in the denominator by itself, but if the numerator and denominator are equal to each other, then that fraction just reduces to 1, and I can multiply by 1 without changing the problem. So we've seen that early on in just basic math with arithmetic and getting common denominators. That is a common technique, is to multiply by 1, but to rewrite 1 where the numerator and denominator are equal to each other. Now here, this term is missing an x plus 2. So again, what's in green there is the number 1. It's just, I goof around and I say it's in disguise. Alright. On the right-hand side, we have this number 1, but we're going to rewrite 1 as it's missing both. So we're going to rewrite, we've got x plus 2 over x plus 2 and x minus 2 over x minus 2. 1 times 1, that's 1. Alright. Now that we have a common denominator everywhere, this denominator, we've cleared the denominator. If we multiplied every term by that common denominator, all of these denominators would cancel. What we'd have left is the operations in the numerator. We've got x times this quantity. Now don't forget your parentheses. You need to multiply both of those terms by x. And the same comment with the 3. You need to multiply both of these terms by 3. And here we have a special x plus 2 times x minus 2. If you don't recognize that that's a special product, then you could create your table or however you multiply binomials. If you spell out FOIL or however you do it. But this is just x squared minus 2 squared, x squared minus 4. Alright, let's distribute that x. I get x squared minus 2x. Let's distribute the 3. 3x plus 6. Let's multiply this special product and get x squared minus 4. So this is a quadratic equation. The biggest exponent on the variable is 2, but I also notice that if I subtract x squared from both sides, that this x squared and this x squared cancel. And so what do we have then? Well, 3x minus 2x is just an x. Let's subtract 6 from both sides. And I have here a solution x equals negative 10. Now, I know that that's a solution to this equation. I know that that's a solution to this equation. And our technique says that the solutions to the original equation and the one I've highlighted in yellow are the same solution set, except when we clear that denominator, we could have introduced extra solutions to the equation highlighted in yellow that really are not solutions to the equation we're trying to find. So our technique forces us to check our answer. It's probably a good idea to check our answers anyway for arithmetic error, but this is required. It's a technique of the solution. So I need to plug in -10. So let's pull up my calculator here. I'm loving this calculator more and more as I use it. However, I don't like that I still have difficulty seeing that shades of blue, using these alternate functions here. But hey, we'll get used to it. All right, so this first fraction, this first term, is -10 divided by, and remember when you're, now I know that -10 plus 2 is a -8, so I guess, if I were to key in some complicated denominator, you want parentheses around it if it's more than one term. But with -10 plus 2, that is -8. There are some arithmetic that I'm okay with. All right, a -10 minus 2, -12. So on the left-hand side, when I add these two fractions together, hey, I get 1. And that was what I have on the right-hand side. So I claim that this guy does check, and that's my solution for problem number 1. All right. Let's move on to problem number 2. Problem number 2 is slightly different. We don't have a variable in a denominator here. So I think a student could technically argue that checking our solution is not part of the we're concerned of extraneous solutions there when we have that variable in the denominator when I multiplied both sides of this equation by that common denominator that had a variable. We'll see here our common denominator does not have a variable, so checking the answer is technically not part of this. A lot of times they won't even call this a rational equation. It's in reference to if there's a variable in the denominator. But other textbooks do say simply, hey, if the equation contains fractions, it's a rational equation. All right, so I look and I see that there's 3 terms. There's 2 terms on the left-hand side. There's a single term on the right-hand side. I can rewrite this 3 as 3 over 1. I look and say, hey, the least common denominator of 3, 5, and 1 is 15. So we want to write each of these terms as a fraction with a denominator of 15. So this guy is missing a factor of 5. So 5 divided by 5 is 1. Now this other term, this x minus 1 over 5, it's missing a factor of 3 in the denominator, so we multiply it by 3 over 3. Now on the right hand side, this 3 over 1, well, that 1 is not 15, so I multiply this by the number 1 and write it as 15 over 15. Alright, so this denominator, 3 times 5, hey, it's 15. 5 times 3, hey, that denominator is 15. And this denominator is 15 because, when we multiply fractions, it's easy. You don't have to get you just multiply the numerators and the denominators together. Multiplication and division of fractions is much easier than addition and subtraction of fractions because with addition and subtraction, like with that subtraction, we need a common denominator. So if I multiply every one of these terms by 15, all those denominators are cleared. And see, when I'm multiplying both sides by 15, that's different than multiplying both sides by a variable. Multiplying both sides by the variable introduces the possibility of extraneous solutions. This is not going to introduce the possibility of an extraneous solution, multiplying both sides by a 15. So I'm going to write the 5 first. 5 times x plus 5. Now I do need the parentheses there. Minus, I'm going to move this 3 to the front. See the order, if I multiply 3 times the quantity x minus 1, or if I multiply x minus 1, that quantity times 3, it really doesn't matter. It's just that most of the time you will see people, teachers and students with experience write those constants as coefficient out there in front of the binomial. But since multiplication is commutative, you don't have to do that. 3 times 15 is 45. So let's distribute 5x plus 25 and distribute, and at the same time try not to make sign errors. Alright, we have like terms there and there. That's a 2x. We have all of these constants that we want to build on the right hand side. So the 45 is exactly where we want. The 25 and 3 is 28. So I want to take 45 minus 28. I don't want to make a silly mistake on the video. So hey, 17. I knew that. Alright, and then 17 divided by 2. Now, even though I could argue that, hey, I don't have to check this answer because it's not going to be extraneous, I am going to check my answer just because I'm afraid I might have done some arithmetic wrong. And I've got a calculator, so it's not too hard to check it. If I plug in 17 over 2, I'm going to put parentheses in this numerator. So this, everywhere I see an x, I punch in 17 divided by 2, and then plus 5. That's my numerator. I close that parenthesis, and that's being divided by 3. Now, that's my first term. And, hey, that first term is 4.5. Now I'm going to subtract. See, the calculator remembers that answer of 4.5 if I hit minus, and now in parentheses, I've got 17 divided by 2 minus 1. That's in my numerator. I'll close that, and I divide that by 5. Alright, so these two fractions, the difference of these two fractions, the claim is that it would be 3. So if I hit this equation, equal enter, and I get 3, I'm pretty confident that that's the correct solution. Let's see what happens. Drum roll, please. Hey, I got a 3. So this checks. I need to come up with a little button over here that has sound effects as I'm making these videos. If not to make you laugh, just to make me laugh. Alright. Number 3. And I believe that somebody in one of the classes today in third period that she asked to see number 3, and I said, hey, I'll make a solution of it, and then I thought, well, I'll put it in a video. Alright, so what do we have here? Well, we have two terms on the left-hand side. We have a single term on the right-hand side. Now, when you see a minus sign out in front of the fraction, you can place that minus sign in the denominator, but you would have to change both signs, or you can place it in the numerator. So, to help people not make a silly sign error, I'm going to move that negative sign to be with that 4. So instead of positive 4 divided by that number, it's negative 4. Alright. I can't factor this denominator. I can't factor this. I can factor the denominator on the right. So let's do that. We've got 2x minus 1. And I'm going to leave a little bit of space here. And I've got 4 over x. And I'm going to leave a little bit of space here. And I think you'll see why right now. Because if I look at these two terms, they have an x in common. And I have x times the quantity, 2x minus 1, if I factor that. So that's the denominator that I want to see in these other two terms. Well, we've seen that technique before, that we're going to come in. This first term is missing that factor of x, so we're going to multiply by x over x. That's multiplying this term by the number 1. So we haven't changed the equation. We haven't changed. We're going to get the same solution set. Now over here, I left room here. Maybe not enough room, but I left room for this missing factor of 2x minus 1. But I need this to be the number 1, so the denominator and numerator have to be the same thing. Now, this has the denominator that I wanted, so I leave it alone. Alright. When I have a common denominator everywhere, if I were to multiply every term by that common denominator, they would all cancel. All these denominators would cancel. And so I get x squared plus 4 times the quantity. I do need parentheses around this because I do have to multiply both of those terms by 4, not just my favorite term. And remember, I moved that minus sign up here so I wouldn't make a silly error. Now, in multiplying all of this by this least common denominator, this equation and this equation may not have the same solution set. You know, they will, but the gray might have extra solutions. And so with respect to the yellow equation, we call those equations that satisfy the gray but don't satisfy the yellow, we refer to them as extraneous. Alright, this guy is a quadratic equation, so I want to try and get it in standard form and then either factor or use the quadratic formula. So I've got x squared, or I could complete the square as well, because completing the square and the quadratic formula, technically that's really the same thing. How did we get that quadratic formula? They derived that by completing the square. At least that's how I think of it. Alright, with a negative 4 on each side of the equation, if I add 4 to both sides, that cancels. And now both of these terms have an x in common, so I factor that out. And by my zero product theorem, if you have a product of numbers that multiply to give you 0, either one or both of these numbers have to be 0. So this first one, x equals 0, hey, that's solved for me. And if x plus 8 is equal to 0, that's a one-step solution, negative 8. But we've got to check. And look, immediately when I plug in the 0 into this equation, look at that 4 divided by 0. When you try on your calculator to take 4 divided by 0, you're going to, you know, if I was the programmer of this, I'd have artificial smoke coming out of this whenever you try and divide by 0. But it's just going to say something dull like domain error, or, you know, it's going to come up with a message. Yeah, see, error, divide by 0. I'd have cool sound effects of smoke coming out and a little maybe lava fire or something on there just for fun, but Texas Instruments being super serious with their calculator. Okay, so that guy's extraneous. It's gone. It's out of here. Alright, so let's plug in and check this negative 8 into here. And let's bring our calculator back up. The negative 8 in the numerator. In the denominator, what do we have? Well, the 2 times negative 8 is a negative 16. Minus 1, I've got a negative 17. Now, I did, you know, if you wanted to, you just could have let the arithmetic, you know, let the calculator do the work and calculate that negative 17, but I did it. You know, like I say, there's some basic arithmetic that I'm capable of doing. 4 divided by negative 8. So on the left-hand side, I'm getting this ugly decimal number. Let's check and see if on the right-hand side we get that same ugly number. We've got this negative 4 divided by the quantity 2, and now the x squared, well, that's negative 8 squared. Hey, 2 times 64 minus a negative 8 is really plus 8. Close my parenthesis for the denominator. So that's that fraction on the left-hand side, and I'm expecting that it's probably going to be equal to that, but let's see. And there we have it. You know, and that's what, out to 9 decimal numbers. Sometimes you may have these last digits differ because of round off error for some reason if you have plugged in some value in your head, but I mean they should be, like, these are equal to each other, those decimals. So I'm pretty confident now that for number 3, that x equals negative 8 is my only solution. That x equals 0, it satisfied this gray equation, but not the equation that I wanted. It's extraneous in reference to the to the yellow equation because it caused division by 0. Alright, so let's take a look then at our next one, number 4. And hey, you're jumping up and down for joy because this is a true proportion. This is where you cross multiply. We could get a common denominator. We could do it the other way, but it's just going to be faster and easier. And students love to say they're cross multiplying, but you only cross multiply when you're multiplying along the diagonals, not canceling along the diagonals. And when you're crossing over that x, I mean that's what I've always thought that was referred to as cross multiplication. All right. Along this gray hey, let's put that negative sign, make a decision in the numerator or the denominator, but not both. So I'm going to make that negative sign. I'm going to move that negative and associate it with a 2. If you wanted to, you could have came down and made that negative, take the opposite of each one of these terms, the opposite of a plus 1, and you would get the same solution that we're going to get. But I think that you'll find it easiest to just move that negative up to that numerator there because it's just a single term up there. Alright, if I multiply along that gray diagonal, I have negative 2 times a minus 6. And if I multiply along this yellow diagonal, I have a times the quantity a minus 1. If we distribute the negative 2 through, we have negative 2a plus 12. And over here we have a squared minus a. So this new equation is not the same as our original equation. We've cleared the fractions. In multiplying, though, we could have introduced extraneous solutions because along these diagonals, these were variables and stuff there. So this is a quadratic equation. Let's get this in standard form, and then let's remember to check our answers. So I'm going to have this left side be 0, and I'm going to add 2a to both sides. When I add 2a, and here I have a negative 1a, that's going to change to a positive 1a. When I move that 12 to the other side, I subtract it, so I'm going to have minus 12. When I factor this, a times a gives me the a squared, and I'm going to have a positive 4 and a negative 3. The product is negative 12, but the number that's larger in magnitude is positive because that middle term is positive. 4 plus a negative 3 is positive 1. Now, negative 4 and positive 3 are my possible solutions at this point. I'm not ready yet to declare them in the solution set until after I've checked them. And the technique tells me that I have to do that. Alright, so if I plug in negative 4 on the left-hand side, I have negative 4 divided by, well, negative 4 minus 6 is a negative 10. Okay, so on the left-hand side I'm getting 0.4. On the right-hand side, remember we have that negative being associated with the 2. And if I plug in negative 4 minus 1 is a negative 5. And I get 0.4. So this guy, it checks. Let's plug in 3. We've got 3 divided by 3 minus 6 is a negative 3. So on the left-hand side we have a negative 1. Let's see what we have on the right-hand side. We've got negative 2 in the numerator, and the denominator 3 minus 1 is a positive 2. Negative 1 does equal negative 1. Now remember, I'm not saying my answer is negative. I'm saying that when you plug in this answer of a equals 3, that resulting arithmetic on the left-hand side and the right-hand side was negative 1. So these are my solutions. This was just my left-hand side and right-hand side of the equation after I did that arithmetic. That was checking my work. Alright. Move on now to number 4. Oh no, we just did number 4. To number 5. I have 3 terms in this equation. The first term has a denominator of x minus 2. The second term isn't written as a fraction, so I'll just make it a fraction by placing it over 1. And this last term, the term that's on the right-hand side, is x plus 2. So I want the same denominator for each of these 3 terms. In this first term, it's this denominator is missing a factor of x plus 2. So we multiply by the number 1, but we write number 1 with the numerator and denominator being the same. And now to rewrite this number 1, well, I need an x minus 2 in the denominator, and I need an x plus 2 in the denominator. So since numerator and denominator are equal, this is 1, and the numerator and denominator, this is 1, and 1 times 1 is 1. And I have addition here, so I didn't change the operation. So on the left-hand side, we're now good. We've got two fractions, and they both have the same denominator. On the right-hand side, what do we have? We have x over x plus 2, and I am missing a factor of x minus 2. Now all these denominators are the same. So if I multiplied every one of these terms by that x minus 2 times x plus 2, all those denominators would cancel, and I'm just left with the numerator. But in multiplying both sides of this equation by a variable, I introduce a possibility of solutions to my new equation that aren't solutions to the original. Let's take this x times x plus 2, and this guy is a special product, and x times a quantity x minus 2 there. Alright, if I distribute the x, I've got x squared plus 2x. If I multiply this together, the middle terms will cancel, and I'll get x squared minus 4. And if I distribute that, I get x squared minus 2x. So on the left-hand side, like if I took away an x squared from each side, all I'm left with is an x squared on the left-hand side. If I add 2x to both sides, this becomes 4x. See, sometimes people will accidentally go, well, I've got a positive 2x and a negative 2x, they cancel. Well, they would cancel if they're on the same side of the equation, but on opposite sides of the equation, they have to be the same to cancel. So, if I add 2x here, yeah, these guys cancel because they're equal and opposite. I've got to add 2x here, and those, I get 4x over here. So be careful. Don't be cancel crazy. My English teachers used to tell me that I was a comma pirate, that I kept putting commas where they either didn't belong or I stole them, vice versa. Alright, we can factor this guy to x minus 2 quantity. No, I cannot do that. Let's double check my work here. How did that... I'm going to pause this real quick. Alright, is this recording? I believe I'm back. No? Alright, is this recording? Yeah, no? When that's blinking, I assume it's recording. You see this 2? How did it mysteriously, why did I change that 2 to an X? Maybe when I did it you were screaming at the video, hey, that this should have been a 2. That why did he look at 2 and write X? Alright, so hey, that error continued all the way through. So this I know should be a 2. And now I'm not going to try and come in and make my correct. I'm just going to try to yeah, I could black it out. I'm going to that's a small eraser, and I want it to be a large eraser because I made a major mistake. Sorry about that. So let's erase where my mistake occurred, and let's look below here. Let's correct this. Sorry about that. All right. when I distribute this, well, when I clear that fraction, I have 2 times the quantity. Let's make it a little bit thicker because that's difficult to see. We've got 2 times the quantity x plus 2, not x times the quantity. Over here, we've got x minus 2 times x plus 2. And see, there's the x. You know, maybe somehow I looked up and saw that. Who knows what I did? Who knows what I ever do? Distribute the 2. 2x plus 4. X squared minus 4. Distribute this. X squared minus 2x. Quadratic equation. Because the biggest exponent on my variable is a 2, let's get this in some kind of a standard form. Now, I spoke too quickly. Since this x squared and that x squared are the same, this simplifies to an equation that is not quadratic. So generally, a linear equation is usually easier to solve. Let's add 2x to both sides, and over here it becomes 4x. And hey, this positive 4 and negative 4 on the same side of the equation, they cancel. So and I moved that over. Hey, this is just 0. Alright, and x equals 0. So we've got to, that doesn't cause division by 0, but we're going to have to check that because we don't know if that satisfies the original equation. So arithmetic with 0 is pretty easy, so let's not bring up the calculator. Let's see if we can do it. If this is 0, we have positive 2 divided by negative 2, which is a negative 1. And negative 1 and positive 1 on the left-hand side, hey, arithmetic happens to be 0. Now the big question is, on the right-hand side, hey, we've got a 0 in the numerator, and now the denominator is just 2, but 0 divided by 2 is 0. So this checks. Okay, so I'm pretty confident that 0 is in my solution set, and I think that it will be the only value in my solution set because my quadratic terms canceled. I don't have another solution here. All right. Let's come in and we'll make this problem the last one in this video and call it part 1, and then I'll do it in part 2 because I still have a lot of other things to try to do as well. But this can help push people into a direction of understanding the material maybe a little bit better. Alright, so I have 3 terms. On the left hand side, I have a term with a denominator of a plus 2. On the right hand side, I have 2 terms, and this denominator, maybe it's difficult to see what those factors are and how I'm going to get a common denominator, so I need to factor that. So the left hand side, I'm going to leave it alone. And on the right hand side, I know that this factors, because it's a difference of squares, to a plus 2. My 2's and my a's look so much. Let's try to, looks like a stupid 2. A plus 2 and a minus 2, that product is a squared minus 4. And now I have 1 over a minus 2. Alright, so hey, this guy is missing a factor of a minus 2 in the denominator. This guy is missing a factor of a plus 2. So let's come in and multiply each of these terms by 1, but let's write 1 as a minus 2 over a minus 2, and over here we'll write the number 1 as a plus 2 and a plus 2. That's a goofy looking. I don't know if that's much better. Now I have the same denominator everywhere, so I can focus my attention on the numerator. My resulting equation does not have any variables in the denominator, and it's going to be easier to solve. But unfortunately, we may have, when we clearing this fraction, we may have introduced extraneous solutions. I don't have to put that 1 there if I put parentheses around the a plus 2. See over here, I forgot to do a. Hopefully you can see the difference between the a and the 2 there. Alright, so I've got a minus, 2, and 4 minus a minus 2. Let's add a to both sides. My normal way of writing my 2's look so much. I should just stop using the variable a. Alright, because I can't stop using the number 2. Let's add 2 to each side. And, well, actually let's recognize that if you have the same number on this side of the equation and the same number on that side of the equation, they just cancel each other out. So I get a possible solution of 2. But look at this. When I go in to check my work, I knew at the beginning of this problem, if right here when I factored this, I could have made the remark that a had better not be negative 2 and that a had better not be positive 2, because those would cause division by 0, and division by 0 is undefined. So this is extraneous solution. It was a solution to this equation when we cleared our fractions, but it is not a solution to our original equation. So my final answer is no solution. Now, with all the internet problems that we've had, I don't have a problem recording this video, but I have been having problems uploading the video, that it just times me out. It just won't do it. So I'll try and do it either from home, but I'm having problems with my own personal computer at home, or in the, I doubt in the early morning hours. I don't think that it's after 6 o'clock in the evening now, and when I come in the morning, I don't think that anybody will have worked on trying to get the internet up and working, so it may not be until my prep tomorrow, second period, or later in the day that I can upload this video. So I am trying to get information to you, and if you ever need any extra time in turning some work in, just let me know, and it will be granted. Alright, so hey, part 1 is out.